Okay, let's say you talk about something like a hot question. Let's say in the first attempt you don't understand the details. It's okay, just watch it again. So when you watch it a few times, right, then you'll be like, oh, finally I know it already. Or maybe let's say you do a hot question, for example. Then you do already. Let's say you don't know how to do, but your teacher gives you the answer, you jot it down. Then once you jot it down, then probably you remember how your teacher do it lah. Then you repeatedly rewrite it according to your memory. Then suddenly on the maybe third or fourth attempt when you're doing it, suddenly you understand it. Yeah, like of course you don't do it like right after you do the question. Probably like next day you try again. Maybe like another 2 days you try again. Then suddenly you were like, oh, okay, refresh. Serious? Okay, I always have this feeling. Yeah, when I'm in like 4.4 and 4.5 when I do next question. Now, first of all, this is last page, and you jot it down as an extra question. This question originally it was from CHS, okay, my ex-school, okay. So this question is like super powerful, where I think worth sharing with you all lah. So it's like a question where I don't think you will get it in your exam anymore, but it's worth sharing. Okay. So first of all, everyone, the first point I want to explain to students is where I remember on our previous field class we have been talking about this experiment about what? About experiment about cross-section. Remember uniform cross-section? Yeah, we talked about uniform cross-section versus cross-section. Remember? Uniform cross-section versus non-uniform cross-section. Okay, so what's so special about this cross-section and uniform cross-section? I remember I said something about cylinder being a uniform cross-section, and what is the non-cross-section to it, everybody? Can you tell me in chat? Yeah, what's the non-cross-section to your cylinder? Okay, very good. Okay, very good. So you managed to know it. Okay, so it's it's your cone. Very good, it's your cone. So you notice you get the same height, you get the same radius, right? And I told you about the experiment, and I said eventually, so I told you about the ratio. Okay, I said for your uniform cross section and your non-uniform cross section, we have this ratio of what to what, everybody. Thank you very much. You have this ratio of 3:1. Remember about the experiment? I said you fill water, then after you transfer, right? Okay, so we're not going to talk about that. Okay, so we know the ratio already. So therefore, when you read this question, okay, the question says, a cylinder, a cone, a sphere have the same height and radius. Okay, so this one fits the condition. If the volume of the cone, 180 cm³, find the volume of the cylinder and sphere. Okay, cylinder is not like something special, you know that. Okay, students, tell me what is your cylinder's volume. Okay, very good. So we managed to get the answer already. So we know like cylinder to cone to sphere. So we know this is 180 cm³. I'm not writing that. Then you know your cylinder definitely will be 180 what? Because you know the ratio is 3:1. So if let's say your cone is 1, which is 180 degrees, then the other side we talk about cylinder, it will be triple. So you times 3. So what do you get? You get 540. So nothing much. This is the starting part according to what we have learned on the previous class. Okay. Now, but the problem is the sphere. Yeah, the problem is the sphere. Okay. So on the second part, right? Okay, on the second part of the explanation, I'm gonna say, okay, I remember I've been like telling you don't memorize the formula, but there is one formula. I said too bad. As for your Form 2 level, you have to memorize it because you need something higher level to prove the formula, right? So what is that formula? Okay, what is that formula for volume of sphere, everybody? Okay, volume of sphere. So volume of sphere, you have 4, thank you, 4/3, very good, pi r cubed. And let's say we talk about, I said don't memorize your what's it called, your volume for cylinder and cone, but we know that according to what I taught you, I said as long as you got your cross-section area, just one of it, which is pi r squared, then you times with the height between them, then you will get the answer already, right? So that's what we mentioned. So for your volume for cylinder, it will be pi r squared h, and for your non-cross-section, that cone there, simple, it will be pi r squared h divided by 3. So we have all the formula there already, see? 1, 2, 3, we have 3 formulas. So students, now I'm going to redraw. Okay, I repeat. Now I'm going to redraw. See, I'm going to redraw it. I will purposely fit the what? I will purposely fit the sphere inside. Okay, here. Look at this. So I'm going to fit the sphere inside, no? Okay, then you're going to tell me some common sense, So I'm going to fit the sphere inside. Wow, so it's like nicely inscribed. Just nice. Fit inside. So obviously, because they say same height and same radius, so radius is 100% same radius. But students, can you tell me what is the height to your sphere. This is that breakthrough, you know. You have two breakthrough here to solve this question. So the first one, very good, Jumbo. Okay, very good. So anyone else? So what is that very important extra information that break through to the question? So students, radius is like same already, you know that because according to the question, and I purposely redraw it like this, you know. So what is the height of the sphere? Now I tell you something, student definitely gonna say this thing on, teacher, you need height, man. Huh? This one formula don't have height also, why you need height? But that's one of the breakthrough. But never mind, because you know the height of the cylinder is like just nice the what? Very good, Inja. The diameter of the whole thing. Is the diameter of your sphere, the height of the cylinder, the height of the cone is actually the diameter of the sphere. As well as like what Danusha and Jumbo and who else? Like a few more students. Okay, sorry, I missed out your name. So you all mentioned to me that the height of, don't you think is actually how many radius everyone? There, this one is also radius, fit inside, right? This one is also radius. So therefore, height is actually 2r. So this is like one of the breakthrough. Very good question. So like number 3, I draw already. And now you know what? Okay, students. Now, just like I said, a common sense question that you want to answer me, right? Okay, now I'm going to ask. Can you tell me among cylinder, among cone, among sphere that I squeeze inside, I just draw it inside to intersect to show you which solid larger? Come on, obviously, which one larger? Cone is like super small already, right? So the larger one will be cylinder law. That's why I say common sense, man. You look at the picture, you know already. Okay, so I will use cylinder as a standard to compare lah. So part 4, okay, part 4 explanation. I'm going to do it this way. I'm going to use cylinder formula, which is pi r square h. You see, pi r square h to directly compare to my sphere, which is 4/3 pi r cubed. Then student will start asking me, teacher, why you have to use ratio? Okay, like 2 reasons. Okay, reason number 1, because that's how we have this ratio to compare cylinder and cone. Then of course, next, why I use cylinder? I already said cylinder is the largest. I'll use it as a standard to compare. And of course, finally, since I'm using cylinder as a standard to compare, because I'm comparing to what? I'm comparing to sphere. Now, then I put it side by side, and of course, most importantly, ratio, you can turn into fraction. So when you turn the ratio, you see, when you turn the ratio into fraction, you see, you turn this ratio, okay, A to B, this one you see, it's A to B, when I turn into fraction, you see what happened? Pi r square h over 4/3 pi r cubed. You tell me what happened if I change into fraction? I mean, you can turn into fraction because like form 1, you have this like important formats, right, about ratios. So yes, because the best thing here is that once you turn to fraction, you can simplify, you can cancel out. Thank you, Jumbo. So you see, pi and pi you cancel off. So you're like super happy, right? You see, you cut off the pi and pi. Wow. Then the next thing you will get into what? You get into like, teacher, I see r square and r cube. We learned this before. We can cut the r away because r square means rr, r cube means rrr. So when I cut off, right? Can you tell me how many r's you left? You left 1 r. Then some students, they got stuck. Okay, why they got stuck? Why they got stuck? Because they say, teacher, there's 1 h there, 1 r there, how I cut? How I cut? But it's okay, let me tell you why. Now, because just now I said there is one very important breakthrough. I said height is actually what? You told me that, right? I said height is actually 2r. Instead of saying radius, supposed to be 2 radius, So I will, you see, I rewrite, okay, I rewrite it. So now you left h, so h, I will turn it into 2r. And then 4/3, I put it back, r, I left 1. Then now you can cut the r already. So once you cut the r, you notice, this thing, right? You can take 2 divide by, open bracket, 4/3. You have to type in the calculator lah. If let's say you don't want to waste your time, right? So 2, then you're going to over, divide by 4/3. Wow. So you instantly get what? Of course, you don't put mixed number lah. You put like your improper fraction. So you notice this becomes 3/2. So once you get 3/2, don't you think you can reverse it into 3:2? So meaning now you notice cylinder is actually 3, sphere is actually 2. And now when you compare it back to the given ratio, do you notice the cylinder 3 is the same as the 3 here? So now you know your sphere is actually 2. So what you're going to do to your sphere? You're going to take 180, which is from your cone, you times 2. Nice. You managed to get it. Your answer is 360 cm³. So that's how you do it. Understand? So that's why I say this is something I would say, sort of kind of interesting lah. I said, sorry lah, for students that you say maths is like, I hate maths. It's just that I can do it. That's why I teach you. I already said it, right now. I said it a lot of times. So I will make this into a video for you to repeatedly watch it. Okay? One a very interesting question. Okay? So, okay, sorry.